So, first of all, I would like to thank all of you for being here on time, or most of you. And today, what we'll be doing for the next 45 to 50 minutes is give you an overview about electrical engineering in general, and the Department of Electrical Engineering at the American University of Sharjah in specific. And I hope in the next 45 to 50 minutes, you'll find some of the topics that I talk about interesting, and hopefully it will add more to towards your knowledge. Before I begin the lecture, I would like first to introduce myself. So my name is Amer Zakaria. I'm a professor with the Electrical Engineering Department for the past 6 years. So at the end of the lecture, if you have any questions, you can remain in the session, and I hopefully will address any of your concerns. So to start off with, it's a good idea first to understand what's the actual meaning of the two words or the phrase electrical engineering. Now, if you take each word in this phrase by itself, you will understand why is it called electrical engineering. Start off with the word electrical itself, which is an English word. It actually comes from the Greek word, which is electron. Now, most of you probably know what an electron is. If you studied chemistry 101, or if you studied chemistry at school, you know that an electron is a negatively charged particle, which is always rotating around a nucleus in an atom, which is a positively charged center of the positively charged center of any atom. Now, the word electron itself is a Greek word. It's not an English word, and it literally means the word amber in English. Now, I have put a picture in front of you over here on the right, a picture of an amber. Now, you might be wondering, why is electron called amber? Why is electron the Greek word, is amber the English word? The reason behind that has to do with history. The ancient Greek were the first people to discover or to experiment with what we call the electrostatic forces. This is something that you might actually have done in the school, or maybe in physics 102. If you take a piece of plastic like a ruler and you brush it against your hair, and then you bring this ruler close to a bunch pieces of paper, what happens? What do you think? You might have done this before. The pieces of paper will get attracted to that ruler after you brush it with your hair. Yes, as Faisal also agrees. So the reason behind that is because of electrostatic forces due to the charges or the electrons which are on the surface of the ruler. Now, the ancient Greek were the first people to discover that. They took a piece of amber, which is in Arabic called kahraman, as you can actually buy it from a lot of jewelry shops. Also, you can do it with a balloon, Faisal. You are absolutely right. So what the Greek found is that they took a piece of amber and they rubbed it against their clothes, and then they took this piece of amber close to tree leaves, and they found out that it gets attracted to it. So back then, they did not understand that this is because of electrons, and they thought this was some kind of magic. So this is where the word electron came. Like, this is the effect of rubbing amber. So it came with the word electron, and eventually scientists discovers that this effect is called the electrostatic forces, which brings us to the word electrical. Now, if you're an Arabic native speaker, you know that the Arabic word for electricity, good afternoon, Yaman. You know the Arabic word for electricity is kahraba. So if you ever wondered why is it called kahraba? Kahraba is not really an Arabic word in the sense that it has no Arabic origin. Kahraba comes from kahraman in Arabic. So this is actually the reason we call it kahraba. So again, electrical has to do with literally the word electron, which is amber in Greek. Now, what about the word engineering, which is the second part of electrical engineering phrase? Engineering is actually comes from the Latin word ingeninum. And ingeninum literally is to make something move, which is in English means an engine. If you ever think about engines, what is an engine? Engine is any process in which you do some kind of task and this process causes something to move. The simplest of this is in a car. You have the car engine. It burns fuel. If you have a petrol car, a hydrocarbon car, it will fuel in order for the engine to move the wheels. This is called, so you are doing some kind of work. Another example is if you studied in physics 102 or in school, how do you create electricity? You are literally moving charges, either electrons or ions. So when you are moving these charges, these electrons, you are producing electricity. So again, the word engineering comes from the word ingenino, which literally makes something move or makes something work. So if you combine both now electrical engineering together, electrical engineering literally means putting electrons to work. And of course, when you are putting these electrons to work, you are doing that to do a certain task. For example, you can do that to generate electricity. You can do that to use your cell phone. You can do that to turn on the light in the room, and so on. So by putting electrons to work, you can achieve different tasks, and we will talk about some of these as we go through this lecture, inshallah. Now, electrical engineering as a science is actually a bit dynamic and exciting. Dynamic, this means that it's always evolving and it's always changing, and exciting because if you understand what you can do with these electrons when they move, you will know that it's involved in a lot of aspects of our life, and it will continue be parts of our life as throughout this world. So as a study, electrical engineering is a study where we are using concepts from mathematics and science in order to do three things: to generate signals, electrical signals, to transmit them, and to receive these signals. So as an example for you to understand what do I mean by generation, transmission, and reception, or generate, transmit, and receive, in front of you on the slide, you can see three examples of how this is done in different ways. For example, if you look at the smart grids picture, what you will notice in this picture, this is an example of a power distribution system. So for example, in the UAE, the thermal power plant over here can be a plant which is generating electricity using turbine engines that work using gas, for example. And you have, these are very common in Sharjah and in Dubai, and also Abu Dhabi. In Abu Dhabi also, you have a nuclear power plant. So you use nuclear energy to generate electricity. You might also have solar panels, like you have in Dubai and Abu Dhabi. You have the Shams 1 station and Mohammed bin Rashid Solar Park. Both of these, they generate electricity using sunlight. So this is an example of generating electrical signals. Now, when you generate the electrical signal, you want to distribute it to people. You want to actually send it to someone to use. And this is done using what we call transmission lines. And you can, most of the time, see these transmission lines as you drive along the highways. If you drive along the highways, you'll see these huge towers with all these lines which are coming, dangling from them. These lines are used to transmit or to distribute the electrical power generated by these power stations. And another example of distribution or transmission is the power switches that you have at home. At your home, you have electrical cables which are running inside the walls in order for you to get electricity from the power socket. This is another example of transmitting electrical energy. Then finally, you are receiving this energy in your device. For example, you might be charging your laptop, or you might be turning on your TV, or maybe you're charging your cell phone, etc. This is an example of receiving this power in order to in order to make use of it. So this is one example of generating power, generating power at stations, transmitting it through transmission lines, and receiving it at home in order for you guys to make use of it. This is an example. Another example, which you can see at the bottom right of the slide, is the microelectronics. In microelectronics, usually, the easiest example you can think about at the moment is you guys listening to me talk. So what is happening? I am talking right now through a microphone. So my sound is being converted into a digital signal. If you remember from some of your courses, a digital signal is a signal which is ones and zeros. So the microphone is converting my sound to electrical signal. So this is the generation part. Then through the laptop and through the internet, the ones and zeros of my voice, or the signal from my voice, is being transmitted over the internet through your internet service provider, like Etisalat or Do, and you are receiving it at home in front of your screen and you are listening to me. So this is another example of generating, transmitting, and receiving electrical signal. And in this case, the electric signal is my voice. Now, all of this, of course, is possible because of different electronic devices, which usually we refer to as microelectronics. They are small devices that can do a lot of different tasks for us when you get in what we call a circuit. And this is a picture of a circuit with different devices. A third example of generating, transmitting, and receiving electrical signals is the picture which I showed on the top right, which is of Khalifa Sat 1. So in this case, what kind of information I'm generating? If some of you don't know, Khalifa Sat 1, it has actually a camera on board. And this camera takes pictures of different locations on Earth, whether it's the Emirates or maybe somewhere else on the planet. So the generation part in this case is you are generating, you are capturing a picture, and this picture is being generated by the camera. Now, after you generate this picture, you have to transmit it to Earth. So this picture is converted into an electromagnetic signal, and the satellite is transmitting it back to the ground station on Earth. And in this case, for Khalifa Sat 1, this ground station is in Dubai at Mohammed bin Rashid Space Center. Then when the signal is being received by the ground station, the satellite ground station, it is converted into an image, and you guys can, and so that the scientists or anyone who asks for it can see the picture that the satellite have captured. So in this case, this is a different type of generation, transmission, and reception. You are generating the signal using the camera, you are transmitting it to the ground using the satellite, and you are receiving it at the ground station to create an image for us to see. And again, these three examples, this is what any electric engineering system will do. It will generate, transmit, and receive. A fourth example, which is something that you might actually be listening to my presentation on, or maybe you are just using it right now as I'm talking, is your cell phone. Your cell phone is an example where you are generating, transmitting, and receiving electrical signals and information. For example, you might be generating a signal by typing a message on WhatsApp. Then when you press the send button, it's being transmitted using your phone to an antenna on your phone through the space, or through the space surrounding you, and then it's being received by the person you are talking with. So again, this is another example of generation, transmission, and reception. And this is, again, any electrical engineering system, this is what the main objectives of it are. Now, in order to do all of this generation, transmission, and reception, regardless of the system, there is a lot of math and science which is being utilized in order to make this successful. So from my talk so far, you can probably just visualize or imagine that electrical engineering is in a lot of aspects of our life. The simplest one being electricity, just power, just turning the light bulb in your house. there is an electrical engineering system that is responsible for doing that. If you look at the industry, this is a picture, for example, in the middle, you have a picture of a robot helping in building a car. The robot is part of an electrical engineering system where you are controlling different motors and actuators on the robot to do a task. In this case, in order to build a car. Another example, which is on the right, top right, is in the military. In the military, there is different instruments and different machines that makes use of electrical engineering systems. An example of that is the picture which is in front of you, which is of a military radar. This picture you see, this is a military equipment which can be used to intercept missiles which are coming from the enemy, and it can also probably fire back and destroy these missiles. And this is done using electrical engineering concepts and systems. Then if you look at the picture which is at the bottom left, this is something that you guys all are aware of, a cell phone. Your cell phone is one of the best examples for an electrical engineering system. You are using it in order to connect with people, either by speech or by sending messages or pictures or videos. Whatever technique it is, this is a machine which is an electrical engineering system. Now, in the bottom middle, you can see a picture of a robot. And again, robots are slowly becoming part of our life. An example of a robot is a drone. And if you have listening to the news lately, Dubai police and Sharjah police, they're using drones, which are robots, in order to ask people to stay at home. This is another example of using robots, which is an electrical, which is a part of an electrical engineering system, in order to influence our life. Now, finally, the picture which is on the bottom left, this is a picture of a magnetic resonance imaging machine, or you might know it as an MRI machine. This is a machine which you can find in any modern hospital, and it is used to visualize the insides of your body, whether it's your head or your leg. And this is just one example of a lot of machines or electrical engineering systems which are used in medicine. MRI is an example. You have also X-rays. Humaid, yes, Humaid saying Boston Dynamics also has many advanced human-like robots. Exactly. I totally agree with you, Humaid. And actually, the picture of the robot, which is in the middle, is from Boston Dynamics. It's one of their robots that they are actually using for some disaster relief efforts. So yes, Humaid, you are absolutely right. Boston Dynamics is one of the companies that has made a lot of advance in robots. Now, what is common between all of these different fields or aspects of our life is all of these aspects, they will have somewhere an electrical engineering system within them. Now, what about the future? Electrical engineering will still be around, and it will be and it is used mainly to make a lot of the systems, all of the electrical engineering systems that I've been talking about, smart. And this is done using a wide range of sensors and what is known as signal processing. So in front of you over here, you can see 5 different futuristic or things or new things in which electrical engineering systems exist. An example of that is Internet of Things. Internet of Things is when you have different things or different electronics in your house or in a factory or anywhere connected with each other, and they can talk with humans and they can talk with each other without human intervention. So this is known as the Internet of Things. So far, in the past 20 years or even more, the internet can be called the Internet of People. People are talking to each other. Like you are chatting with your friend, you are using Skype with someone, or you are sending an email or looking at a website which was created by a human. So this was known as the Internet of People. Now, as we are moving on in this in the next decade, Internet of Things will become something which is common. Not only people talking to each other, but different machines talking to each other. Another example, which is the second one from the left, is cyber physical systems. Cyber physical systems has to do with any robot which is actually connected to other systems in a smart way. For example, you might have a drone which is hovering over a highway and detecting if anyone is doing a traffic violation. And then it's sending the message to the police station. This is an example of a cyber physical system. Another example of a cyber physical system is you might have a robot at home that is doing the vacuuming for you for your house. So when it's done vacuuming, it will go back to its station to charge itself. This is an example of a cyber physical system. The next thing, which is in the middle, is what is known as Industry 4.0 or Industry 4.0. What is Industry 4.0? It is the fact that all factories will become smart and they will have robots in them, to the extent that all of these factories can totally operate without any human intervention. So, for example, you can think of a factory like, I think Tesla is one of the pioneers in this. They are promising to build a factory that can build cars 24 hours a day using only robots. So imagine that. So there's no human intervention at all. How is this possible? This is possible by having all of these different systems in the factory being smart. They are talking to each other, and they are also communicating with a central station where they are reporting what is happening inside the factory. How is the production line going? How is the machines behaving, and so on. Now, the fourth thing, which is the second thing from the right, is artificial intelligence. Now, artificial intelligence is slowly becoming something which everyone needs to know these days, or needs to understand how it works. And it has to do with machines doing the thinking and the decision making totally by themselves. And this is, of course, done through training these systems in order to do a certain task. And slowly, artificial intelligence is being used in a lot of aspects of our life. For example, in Dubai airport, if you traveled any time, not in the past 2 months, but any time in the past, you probably have these smart gates. These smart gates, they have cameras which take a picture of your face, and it can directly recognize who are you, and based on that, it will allow you to pass through the security gate or not, or the passport control or not. So this is another example. Artificial intelligence is essential in our life. Another example of artificial intelligence in our life is these days, scientists all over the world, they're using artificial intelligence in order to find a cure for coronavirus, for example, or a vaccine for it. And so artificial intelligence is becoming an important aspect of our life. Finally, you have something called a smart grid. What is a smart grid? It is when the power systems from the generation to the transmission to the reception is smart. So if any part of the system goes down, it can directly be detected and it can be corrected. Another example of smart grid is, for example, if you have a solar panel at your house, and this is actually one of the initiatives by Dubai Electricity and Water Authority, DEWA. You can have a solar panel at your house, and this solar panel is generating electricity for you to make use of it. Now, sometimes you might actually generate more electricity than you actually need. So what you can do is you can send this electricity, or you can sell this electricity back to DEWA. So this can be done using smart sensors, which is part of a bigger grid, which is known as a smart power grid. So again, electrical engineering, as we go into this future, different fields of it will help to make these systems smart. Now, other electrical engineering activities, including to what I have mentioned, is something, the four which is shown in front of you: services, management, technical writing, and sales and technical marketing. To start off with, what is services? After you buy an electrical device and you deploy it, you will need to make maintenance for the device to make sure that it's always functioning properly. This is known as services. And in addition to building new things, electrical engineers need to know how to fix things if they go bad. Another example is technical writing. Technical writing has to do with what we refer to as writing standards. What are standards? Standards is when you actually, if you want to build any new system, you want to make sure that it's working the same way for everyone. In order to ensure that, you need to write standards, and there are so many standards that you guys are actually making use of, but you are not aware. For example, if you look at your phone and you see that you see these letters 4G plus or 4G LTE. This means that your phone is using a standard which is called the 4 generation standard in order to receive reception from Etisalat or Do. This is again a standard to make sure that everyone who's using 4G are having the same experience. Another example of standards is the Wi-Fi. If you ever buy a Wi-Fi router, you'll see that it says it supports IEEE, IEEE, Wi-Fi 802.11 A, B, C, and whatever. This refers to as a Wi-Fi or a wireless standard to make sure that your system is working properly. Next, we have management. Management, it's more for the people who have a lot of experience. Instead of always working individually, you need to work in a team. And if you work in a team, usually you will probably have to, as you become more senior, you'll have to manage people. So instead of doing a lot of technical work, you need to also have some managerial skills. Finally, sales and technical marketing. What is this about? Usually, if you build a new service or a new device, you need to know how you need to sell it to people, right? And the best person to sell a device or a service which was built by them is an engineer. For example, if I build a new phone, the best thing to sell it to people is to understand the aspects of it, and based on that, be part of the sales team in any company to sell the device. So, based on my discussion or my talk past almost half an hour, you can probably visualize that electrical engineers, they actually work everywhere. They work in research, development, and innovation. For example, in companies like Google and Apple. They work in utility companies like Siwa and Diwa and Adwiya or Fiwa. They can be working in renewable resource design and installation. As an example, Tesla or Mohammed bin Rashid Solar Park or Masdar City. They can be working in oil and gas exploration. As an example of that is ADNOC. They can be working in engineering consulting firms like Haptur or Araptic and so on. They can be working in government regulatory agencies like the TRA, the Telecommunication Regulatory Agency, or UAE Space Agency, or the different ministries in the United Arab Emirates. They can be working in communication, for example, like Siwa and Diwa. Like Etisalat and Do, not Siwa and Diwa. They can be working in computer and data processing services, like, for example, IBM and Oracle. They can be working in universities, like our own university, as professors. They can be working in hospitals, like University Hospital of Sharjah or Rashid Hospital. They can be working in the military, like the UAE Army. They can be working in factories, like in the different factories which are found in different parts of the Emirates. And they can also be working for manufacturers of electrical equipment and components like Sony, Apple, and so on, and whatnot. And they can also be working in space centers like NASA, Mohammed bin Rashid Space Center, and so on. So electrical engineering, they are everywhere. Now, if we look at where the graduates from the electrical engineering program at AUS work. This is just a slide showing some of the companies where electrical engineering alumni actually are working. And it ranges from American University of Sharjah all the way to Apple in the United States. So electrical engineering alumni at AUS work everywhere, and we are really proud of them. Now, some electrical engineering graduates, they decide they don't want to go to the industry directly. They want to continue and do graduate school studies like a master's or a doctor of philosophy, a PhD. And to do that, our own alumni have actually went to all of these universities and even more that in order to pursue their degrees. And again, at an electrical engineering department, over the past 20 years, or actually 22 years, since AUS has been established, we have more than 70 graduates of the electrical engineering program at AUS who have already obtained their PhD, so which is the highest degree you can get in education. And again, we are very proud of our students. Now, what's important to note is that yes, electrical engineering, electrical engineers, and in electrical engineering you can do a lot of things, but you cannot do these things alone. Electrical engineering, like all the engineering disciplines in AUS and in the world, it's a multidisciplinary engineering. So this means we need to work with other engineers like computer engineering and computer scientists, mechanical engineering, civil engineering, and so on. So by working together and being part of a team, we can actually successfully build a complete system. Electrical engineers alone, they cannot build everything. We always need the help of other engineers in any given system. One of the good examples of an electrical engineering, not an electrical engineering, but a multidisciplinary project where you need a lot of engineers is the picture which is in front of you, which is in the International Space Station. Some of you might have heard about this space station in last November or last December when the first UAE astronaut traveled to it. If you look at this International Space Station, a lot of engineers are involved in it. You have electrical engineers who can be responsible for building the solar panels or the solar sails, and of course, creating the power system and the communication system on board the station. You have computer engineers or computer scientists who are responsible to make the different microprocessors and computers on board the system work properly and being executed properly using their own programs. You will have chemical engineers who will help to maintain different life supporting equipment on board, like equipment to make sure that the oxygen levels on board are correct and systems to get rid of any dangerous gases. You will have mechanical engineers who are who might contribute in building structure itself or the different robots. Like example, there is a robot in the location which I'm pointing at over here, which is built by a mechanical engineer. You might have civil engineers working in the project in order to make sure that the design of this structure is sustainable or it will not collapse on itself. And of course, you always need industrial engineers in order to help in managing different aspects of the project and making sure that all of us engineers work together. So again, a lot of engineering projects is not a project handled by a single person or a single engineer, but by engineers from different backgrounds. Another more recent example of engineering coming together and coming up with a very exciting new product is the picture of the Cybertruck, which you can see in front of you. This is a pickup truck which has been released by Tesla or announced by Tesla 2 months ago or 3 months ago. And if you look at this truck, this is totally out of this world. It's something which no one have seen before, and it's expected that with this kind of design and the different new systems which are in this car, there is a lot of changes that will happen to the car industry. So again, this is another example where engineers from this different disciplines are working together to come with a fantastic product. So in the remaining part of this presentation, I'll be mainly talking about the main fields in electrical engineering, and specifically the ones which are, I can say, that are being covered in AUS. And as you can see in front of you in this slide, electrical engineering fields can be roughly divided mainly into 6 different parts, starting with, from the top left, communication and electromagnetics, electronics, digital signal processing, control engineering, biomedical engineering, and power and energy. So in the next few slides, I'll be talking about each one of them separately and how they actually affect our life. So starting with communication in electromagnetics, first, what is communication? Most of you, they communicate with people probably every day, either by talking to someone in front of them or by chatting on WhatsApp. This is known as communication. You're exchanging information between others. So in electrical engineering, this is the same. Communication or communication engineering is the exchange of information from one location to another. An example of that is radio. When you receive the FM radio in your car, for example, you are receiving the signal from a radio station. Another example is satellite communication. If you have a satellite receiver at home and you have like a dish on top of your house, you are receiving signals from a satellite in space. And this is an example of communication. You have cellular cell phone systems or mobile phones. So your phone is an example of a communication system. You're always talking to someone on the phone and or sending a picture through Instagram and so on. This is again this is known as a wireless communication. Another example is computer networks or multimedia communication. If you capture a video and you want to send it through the internet, you need to compress it and you need to do processing on it. This is part of communication, and this is known as multimedia communication. And last but not least, you have something which is emerging, which is known as vehicle-to-vehicle communication, or V2V. And in this case, you have different vehicles talking to each other. For example, you might have cars in the same road talking to each other, and they might be communicating information related to if is there any traffic jam ahead, or is there any kind of accident, what's the weather condition, and so on. Another example of vehicle-to-vehicle communication is that you might have seen these videos of a swarm of drones flying together in space and making different shapes. This is an example of vehicle-to-vehicle communication. The drones are all talking to each other, and they are talking to a main hub. Again, this is a part of electrical engineering, and this is known as vehicle-to-vehicle communication. Now, another aspect of communication, or an important aspect used in communication, is electromagnetics. Electromagnetics is a science where we study the interaction between light, magnets, and electrical charges like electrons. How do they how they interact with each other? If you understand how they interact with each other, you can use them in different applications. For example, in biomedical engineering, an MRI machine uses magnetic fields in order to create a picture of your head. In computer design and circuits, yes, and Mobin says radars, you are right. I'll talk about this in a minute. So in computer chip design and circuits, you have all of these electronics, they are communicating with each other at very high speeds. And so you need to understand how electromagnetics are involved in there. You have any type of communication system, your phone, satellite communication. an electromagnetic signal is being transmitted in the air in order to receive it by the other end. Again, as Mobin said, radars, yes, radars, they use electromagnetics in order to capture people who are speeding. Okay, you are sending a signal, and then you are receiving a signal back from the car to know its speed. And you have what is known as MEMS and NEMS, micro electromechanical systems and nano electromechanical systems. These systems are extremely small mechanical systems that you cannot see with your eye, and they are found everywhere. They are found in your cell phone, they are found in your laptop, in your car, and they are used to do very delicate tasks. For example, when you are rotating your cell phone, the reason the screen rotates is because inside your cell phone, there is a very small mechanical system that senses the rotation. And this is known as MEMS, micro electromechanical system. A final example where you can see electromagnetics is in security, like in airports. If you have these airport scanners, they can reveal if someone is hiding anything under their clothes, as you can see in the picture on this slide. So again, electromagnetics is another aspect of electrical engineering. Next, we have electronics. And who of you is not familiar of electronics? Electronics as a discipline has to do with the design of circuits with transistors and microchips. And these microelectronic technologies are found in all of our consumer electronics. For example, this is a picture of what is inside an Apple Watch. You have a lot of circuits with millions and billions of transistors that are making different functions for the smartwatch to operate. Another example is the iPhone. This is a picture of an iPhone 6 and 6S, and over here you can see different circuits and different electronic devices. Another example is the PlayStation 4. If you open it up, you'll find this green board, which is a circuit that has a lot of electronic devices on it. And finally, you have a picture of a microprocessor in the PS4 or the PlayStation for it to do or to crunch all the graphics that you can see when you are playing games. How do you create all of these electronics? You start with literally sand or silicon. By refining sand, you can create what is known as a wafer. And on this wafer, you design your circuit or your electronics. Now, this is done in what is known as a clean room or a fabrication room. The reason it's called a clean room is because this room is literally clean. It has no dust particles at all. The reason it has no dust particles is because all of the electronics which is being manufactured are extremely small in size. So if you have any dust particle, it might actually cause the electronic device to fail. So you need to make sure that there is no dust particles at all. And this is done using a clean room. Then, after you fabricate your electronics on a wafer, you build your circuit board, which is usually something you might have seen before. It's a green board which has a lot of electronic devices on them. So this is how electronics are built in just a very concise flowchart. Of course, each of these is a science by itself, and a lot of electrical engineers as well as other engineers are involved in it. Next discipline of electrical engineering that I'll talk about is digital signal processing. So what is digital signal processing? If you look at the world around us, it is continuous. My speech is continuous. When you look at anything on the wall, it's continuous. So in order to process it, you need to convert it to the digital form. Digital means that it's a bunch of ones and zeros. Now, when you convert it to the digital form, you can process it. For example, if you just use your cell phone right now to take a picture, you have converted the picture or the scene in front of you from a continuous form into the digital form, to ones and zeros. Then you can apply a filter on it, Instagram filter. When you apply a filter, what you are doing is you're doing processing. So the whole concept or the whole science is known as digital signal processing. It's the process of converting analog electrical signals to digital signals and performing all sorts of mathematical processes on them. And of course, you can find this everywhere in audio, video devices, in cell phones, in smart homes or Internet of Things, artificial intelligence, biomedical devices, and so on. So again, this is an example of digital signal processing. So an example of digital signal processing is facial recognition, which is known as biometrics. So biometrics, it is features in the face in order to identify the person. And this is found in a lot of aspects of our life. For example, most of modern cell phones, they have a feature to unlock the phone using your face. How is this done? Again, by processing a picture of the face, you can extract features from it, which are different from one person to another. And based on that, you can use these features to identify, for example, this is a picture of a professor. So the features are identified, and then you give the system a new feature, and it tells you that this is a 30-year-old male, a 30 to 35-year-old male. If you get a picture of someone else, it will identify it as a female, and so on. Or you can also use it to identify if the person is happy or sad or surprised, as you can see in the example below. Another example of using digital signal processing is crowd control. So by using a drone that has a camera on it, you can take a picture of a crowd and you can tell how many people are in this crowd, as you can see on the slide in front of you. Not only that, you can also estimate what's the speed at which this crowd is actually moving. So, and this is again example of digital signal processing, which is one of the 6 branches of electrical engineering. Next, we have biomedical engineering. In biomedical engineering, you actually are using electrical engineering systems to improve human health and care. And this is something that you can see in any modern hospital. And in front of you over here, you can see a comparison between an operation room in the 19th century and an operation room in the 21st century. And you can see that in the 19th century, you had a poor fellow sitting on the bed, and you had a bunch of doctors around him to do different tasks. One doctor to measure its heart rate, one doctor to measure its temperature, and so on. But in the 21st century, you can substitute all of these doctors with machines. You can have machine to measure the oxygen concentration, machine to measure the temperature. You can have a machine to take a picture of insides of the patient, like an MRI machine you can see in this room. You can have a robot that is performing the operation with the doctor controlling it from a distance, and so on. So all of these are examples of electrical engineering systems in an operation room. So if you look at biomedical instrumentations, they are everywhere. As I mentioned, from patient monitoring like ECG to monitor the heart, EEG to monitor the brain, blood pressure monitors, blood glucose monitors, and so on. You have biomedical engineering systems like X-ray and MRI. And you have therapeutic devices like ventilators, which are important these days, incubators, and hemodialysis machines for the people with kidney problems. All of these, again, are examples of examples where electrical engineering systems are present. Next, we talk about power and energy. Power and energy, as you probably already talked about it and already show you this picture, has to do with generating electricity, transmitting it, and distributing it for our consumption. So I already discussed this, and Over here is an example of how electrical engineering energy is actually being generated. An example of that is generating energy using different generate energy using different resources. They can be either renewable, like wind power and solar power and hydropower, or they can be non-renewable, like the nuclear and gas turbines that you can see in front of you. This is an example of energy generation. Not only that, you can also, a part of power and energy is power electronics and electric drives. And now power electronics are actually found everywhere, like in electric cars. In order to charge these cars with power, you have charging stations everywhere, which is converting high power from a power station to low power in order to generate electricity in your car. So this is an example of another example where electrical engineering systems are. Now, last but not least, let's talk about control engineering. Control engineering is a discipline in which you use what is known as automatic control theory in order to design systems to do a certain desired behavior. An example of this is autonomous cars. Hello? Can you hear me now? Is it better? Muhammad? Okay, is it better now? Okay. Okay, I'll try my best. Again, let me check my internet connection. So my internet connection is fine at the moment, so I hope it's okay. Is my sound better now? Is it better now? Yes, no? Can you hear me? Okay, I'll try my best. I did not change anything in the setting which is in front of me, so I'm not sure what's going on. Sorry for that. It's just the internet. I cannot. Yeah, something maybe happened with the network. Okay, sorry for that, guys. I've been using the same mic for the past 3 weeks, so it's okay. Can you give me? Okay, I'll be back, and maybe it's because the AC was on. So let me turn it off, and I'll be back. Okay. Okay, I'm back, everyone. So can you hear me better now? I hope so. I turned off the AC. Maybe it was the AC. Okay, thank you all, and Hamid. So I'll try. We're almost done, by the way. So let's just go through the rest of the slides. And thank you, Hamid. You're welcome. So the next thing has to do with, again, control engineering. Control engineering, you can find it in different aspects of our life. And the simplest example I can think of is cruise control in your car. If you ever drive a modern car, you always have this option to make sure that the speed of the car is always set at a certain velocity. So this this system this example is a type of a control system. In this control system, you have something which is measuring the speed of the car and something which is controlling whether your engine will accelerate or decelerate or stay at the same speed. Another example of a control system is a drone. You can have a drone which is going from point A to point B. So this is another example of a control system. The drone itself has a lot of sensors which are connected together in order to do a certain task. Now on the slide, you can see three examples of a control system. Starting from the top, this is a robot which was showcased by Dubai Police 2 years ago in GITEX. This is a robot as an example of a control system. On the bottom left, you can see a picture of an autonomous car or in which you have a lot of sensors for the car in order to drive itself. And lastly, on the bottom right, you have a picture of an automatic defense system. So this system, this control system, it has a radar on the top. This radar will detect if there is any enemy coming close to you. And based on that, it will shoot some bullets on it in order to stop it. So all of these is part of a control engineering system. Now let's look at electrical engineering at AUS, and we're almost done with the slides. Now, if I was in the lecture in the university, I would have shown you actually a video about the different labs in our department. But for now, unfortunately, I cannot show you the video using Collaborate. It will be very slow. Instead, what I will show you is different pictures of different labs we have in AUS. And as you can see on the left, we have so many different labs for the different engineering disciplines at the American University of Sharjah. And these labs are used both to teach some courses and also for students to do their projects and to do their designs, or if they have anything in mind, they can actually make use of these labs. In some of these labs, we actually do offer certificates. For example, we have a drone academy in which you can offer a certificate so that you become a licensed pilot of a drone. And hopefully in the future, we will probably be adding more labs because we have a lot of extra space in the new engineering building. Next, let's look at the electrical engineering program itself. As any engineering program in AUS, the electrical engineering program is mainly divided into 4 parts: general education, which are all the courses, the same course taken by everyone on campus or all engineers on campus, engineering students. We have major requirements, which are courses that teach you the core of electrical engineering. You have technical electives, which are courses you select in electrical engineering. For example, let's say you want to specialize in communication. You can take courses related to wireless communication, multimedia communication, satellite communication, etc. If you want to specialize in power, you can take a course related to renewable power, a course related to power distribution, power protection, etc. If you want to specialize in signal processing, you can take a course related to digital signal processing, artificial intelligence, or pattern recognition. Now, another thing which is required by all engineering students is doing a 5 weeks to 3 month summer internship, and this is done usually done between the junior and senior year. And I would say the jewel of the in electrical engineering program and any engineering program is the design project. And in the design project, it's a project that spans 1 year in which you have to reproduce some work or deliver some work after 2 semesters. Now, like all engineering programs at AUS, the program is both ABIT accredited by the United States and also accredited by the CA in the United Arab Emirates. And we were one of the first programs in the United Arab Emirates to actually receive the ABIT accreditation in 2000 or 2001. Now, if you want to do minors in electrical engineering, we do offer at least 3 minors, which are a minor in biomedical engineering, a minor in renewable energy, and a minor in mechatronics. Now, there is a fourth minor, which is under development, which is a minor in intelligent connected devices, or ICD, and still under development. If you're interested in these minors, please do talk to your academic advisor, and he will help you with identifying your interests. Now, if you are not an electrical engineer, you can still do a minor in electrical engineering. And again, I highly advise, if you're interested, I highly advise to talk to your academic advisor, and he will help you with deciding what extra courses do you need in order to get the minor degree. Now, the last thing was about our department. Please do not ask me about the final exam. Okay? The final exam, everything in the slides and the whole talk is related to the final exam. Please, again, do not ask me about the final exam. I cannot help you with that. Now, the last part I want to talk about, which is which is in front of you, is that we as a department are actually very proud of our students. For the past 22 years, our students have won what is known as the AUS President Cup and Chancellor Cup for more than 10 times, which is the most number of times this cup was most number of times it was given to any department in the university. Not only that, our students have won also national and international awards, and they are everywhere, either in graduate schools in North America and the UK, or at different international companies. So as a department, we are very proud of students, and it's also important to note that we professors cannot do anything without our students. Of course not, Alia. These things are not related to electrical engineering. It's more about the department. The part which is important for the project, or sorry, for the final exam, probably are the things which are about electrical engineering, which we talked about before slide number 35. I hope this answers your question. Now, the last thing that I want to mention is what is known as the IEEE student chapter. Let me finish the slides and then we can answer your question, Yazan. So the last thing is the IEEE student chapter, or IEE chapter. IEE stands for the Institute of Electrical and Electronics Engineering, and it's one of the biggest professional organizations in the world with more than 400,000 members. And in AUS, we have a student chapter, and this student chapter organizes different events. For example, they can organize workshop, field trips, and also every year they have a study tour. And you can follow them on Instagram or on Facebook. You can see the links in front of you. And I believe that most of you have a copy of these slides. Now, these are some of the events which are being held by this student chapter. And of course, this is mainly something which is mainly managed by students with no professor supervision, except for the annual tours. And in the past years, the students have been in different places around the world, whether they went to Germany, France, Italy, Korea, and just this past January, they're back into Italy again. So this concludes the presentation itself. So what we'll be doing for the next few minutes is answer any of your questions, starting with the one which was asked by first Alia and then Yazan. So Alia was asking me about the final exam. So regarding the final exam and what parts of this presentation is important is everything up to slide number 35, okay, which is related more to electrical engineering. I will not, you should not be expecting a question about actually the department. This does not make any sense. The next question that came from me was from Yazan about the midterms. I have no information at all about the midterm exams. So please direct this question towards Mr. or Dr. Aqil. He will help you with this question. From my side, I have no information at all about midterms for this course, any course actually. So please direct your questions to Mr. Aqil. You are welcome, yes. So now the floor is open, or the floor is open for anyone if they have any questions.